Lesson 2, Simplifying Rational Expressions. This is the second part, so it continues on from lesson number 1. So, big things to remember from lesson number 1 with rational expressions. Rational expressions means that you have a variable in the denominator's position. And again, because I have a variable in that denominator, I'm now going to have restrictions, or most likely in a lot of circumstances have restrictions on the denominator. So by restrictions, we look at when can't the denominator, or sorry, not can't, when would the denominator equal 0? Because if the denominator equals 0, I can't divide by 0, which means that becomes a restriction. So to find those restrictions, we let the denominator equal 0, solve for the variable, and that becomes a restriction. Then we looked at simplifying rational expressions, much like how we simplify fractions. We look for common factors between the numerator and the denominator. In this lesson, what that will mean is that will mean a lot more factoring of both the top and the bottom. The last thing is when we are reducing rational expressions, we cancel out factors, not terms. So we have to cancel out an x plus 1 and an x plus 1. We can't just cancel out 2's because there's one on the top and the one on the bottom unless those 2's were a factor of the entire expression. So if we look at class example number 1, we are to simplify these, and then we are also asked to state restrictions on the variable. So before, or when you're stating the restrictions on the variable, if the denominator is not factored, factor it first. So if we look at the top and the bottom, what can I factor, or what can I do on the top? So we've got that flow chart. If the very first thing that we always look for is, can I remove a common factor? T. So if I remove a t, what do I get?
4t squared.
Okay. And if I look at the bottom, can I remove a common factor from the bottom? T again. And then what would I get on the bottom?
2t minus 3.
Okay. And I want to check to see whether or not I've factored the top and the bottom, or I've gotten them to simplest terms. So if I look on the top, I look at this binomial. Whenever we see a binomial, we should be checking for a difference of squares. Is that a difference of squares? Okay, so how would I factor that difference of squares? What would I get?
2t plus 3, 2t minus 3.
Thank you. I also have a binomial on the bottom. Is the binomial on the bottom a difference of squares? No, and it contains no other common factors, so we could say that 2t minus 3 is in its simplest factored form. At this point, now I can look at what my restrictions are before I start canceling things out. So for my restrictions, I let each of these two factors be equal to 0. So in the first one, if t equals 0, that becomes the restriction. T can't equal 0. With the next factor, 2t minus 3, if I make that as a 2t minus 3 can't equal 0, and then solve for t, I would add 3 to each side and divide by 2, so I would get 3 halves. So now that I have my restrictions, I can now look at canceling out factors. So if I look, what factors are common to both the top and the bottom?
2t minus 3.
What about the t's? Are those common to the top and the bottom? So what I'm left with is 2t plus 3. with a restriction that t cannot equal 0 or 3/2. And that again goes to the original equation, because in this expression right here, t could equal 0 because I'd get 3. Or t could equal 3/2 because I would get 6. It's when I introduce it into the original expression that I get a 0 in the denominator. Okay, so if we look at B, if I have a trinomial, we can factor either by inspection, or we can use decomposition, or we can try to use that sight method. The sight method works nicely when I have prime numbers, because in order to get 2x squared, what would I multiply together? 2x and x. So that gives me what my first terms would be in my binomial. And then to get my 3, what would I multiply together? What's the only way that I can get a 3? 3 and 1. I just need to figure out where to put the 3 and where to put the 1 in order to get a positive 5x in the middle. So where would I put the 3? With the 2x or with the x? With the x. Because that would give me a 6x and a 1. In order to make this a negative 3, one of those two terms has to be negative. So I have a positive 6 and a negative 1. That gives me my positive 5. Factor the bottom. I have 2x and x again. And this time it's even better, because the only way that I can get 1 is to do what? 1 by 1. The only thing that I have to determine is what the signs are, because that was a negative 1. So to get a positive x, I would need a positive 2 and a negative 1. Now that my trinomials are factored and I have these binomials, I just want to take a quick check to make sure that none of my binomials are difference of squares, which right from the beginning I can tell you they wouldn't be, because I don't have a high enough exponent. In order to have my binomials possibly being a difference of squares, I'd have to have at least an x squared. So now I can look at my restrictions. What can't x equal? So if I imagine letting this be equal to 0, what would x have to be in order for 2x minus 1 to equal 0? 1/2. So x can't equal 1/2. And if it's x plus 1, x wouldn't be able to equal negative 1. So now I have my restrictions. Now I can cancel out my common factors. What are my common factors?
2x minus 1.
Okay. And the x and the x cannot be canceled out. They're common terms. They're not common factors, because this x is tied to the plus 3 and this one's tied to the negative 1. So then my solution, or my simplified expression, would be x plus 3 times x plus 1. Okay, so let's take a look at C. If I factor the top, a squared plus 2a minus 8, what would I get? Okay, so a plus 4 and a minus 2. And then when I go to factor the bottom, I need two numbers that multiply to 64 and add to negative 20. So negative 16 and negative 4. So my first term would be what? Would it be just a, or a squared? So I get an a squared minus 4 and a squared minus 16. So what do we check for? Are those difference of squares? Yeah, they're each a difference of squares. So I would factor the bottom out with those difference of squares. So I'd have a plus 2 and a minus 2, a plus 4 and a minus 4. Now that my denominator is completely factored, I can now look at my restrictions. So what can't a equal? What values of a would make my denominator equal to 0?
Positive and negative 2 and 4.
So positive and negative 2 and positive and negative 4. Now that I have my restrictions, I can then eliminate my factors. So a plus 4 and a plus 4, a minus 2 and a minus 2. So what does that leave me with for the numerator? It would be 1. And then the denominator would be my a plus 2 and a minus 4. What do you notice about 2a? Can I cancel the top and the bottom out yet? But what do you notice? They've got, the terms are the same, they've just been reversed. So is there anything that I could do to the bottom to make this a positive c and this a negative 4? I could factor out a negative 1. If I took out a negative 1, I get my negative 4 and my positive c, which I guess I could rewrite now as a c minus 4 with the negative 1 on the outside. So again, if I look at my denominator, what can't c equal? Four. And then if I look at crossing out my common factors, what am I left with? Negative 1. So it looks kind of funny because we say that the answer is equal to negative 1, but c can't equal 4 because we always have to go back to that original question. Okay, so if we look at b, what can I factor out of the top? What's common to the two terms? So 2p squared, which would leave me with what? What would that leave me with? So if I remove a 2p squared, I'm left with p minus 2. Okay. If you notice the top and the bottom, the difference in the bottom is that it's not written in descending order. So suppose I rewrote it in descending order. Negative 8p plus 16. What can I factor out of each term? A negative 8. Because if I take out a negative 8, what am I left with? P minus 2, which gives me that common factor to cancel. But before I cancel that common factor, I need to state the restriction. So what can't p equal? 2. Because if p equals 2, I get a 0. Cancel that out. So I get 2p squared over negative 8. Can I further reduce that? Do 2 and 8 have common factors? Divide them both by 2. So if I divide the top by 2, I get p squared. Divide the bottom by 2, and I get 4. That negative, I'm going to bring out to the front. Generally, we don't leave a negative in the denominator's position. We bring it out to the front or to the top. So if we tackle C, what could we do for C? What do we notice about the top? So factor the difference of squares. What do you get?
Minus 2x, 1 plus 2.
Then I need to factor out the bottom. Because 6 and 4 are not prime numbers, I may want to look at this as using decomposition, because it just might be quicker to do decomposition than to try to figure out the combinations. So when I'm doing my decomposition, my sum and product chart, two numbers that add to -8, and they'd have to multiply to a -24, because I'd have to use the outside numbers. So what are my two factors that multiply to -24 and add to -8? Or sorry, add to -5. That makes more sense. Because my -24 is negative, my two factors, I would be finding the difference between them. So if I think of all the possible factors of 24, I have 1 times 24, so that difference would be 23.
It would be
8 and 3. And in order to make that a -5, I'd have to make this a -8. So 6x squared plus 3x minus 8x minus 4. So 1 plus 2x, 1 minus 2x. Now the second step in my decomposition is to factor the groups. So what is common to 6x squared and 3x?
3x.
And when I remove the 3x, what does that leave me with?
2x plus 1.
And what's common to -8x and -4?
-4.
Which leaves me with
2x.
So now I have 1 plus 2x, 1 minus 2x, over 2x plus 1, and 3x minus 4. So what are my restrictions on the variable? What can't x equal? So in my 2x plus 1, what can't x equal? -1/2. And in my 3x minus 4, x wouldn't be able to equal 4/3. Do I have any common factors?
2x plus 1.
Yeah. I don't need to rewrite it. I don't need to pull out a negative, because in 2x plus 1 and 1 plus 2x, both terms are positive, so they will cancel each other out. So then I'm left with 1 minus 2x over 3x minus 4. The area of a rectangular field can be expressed or represented by the expression 12a squared plus 25a minus 7. And the length of the field can be represented by the expression 3a plus 7. Write and simplify a rational expression which represents the width of the field. If I have area and length, how do I find width?
Divide the area by 1.
So width would equal 12a squared plus 25a minus 7 over 3a plus 7. So what would I need to do to the top? If I have to simplify a rational expression, what do I want to do with the top expression? If I had 24 over 4, what would I do? How would I simplify it? Divide them both by 4. Because 24, I can write as 6 times 4, and what am I canceling out? Common factors. So what do I need to do with my expression that's in the numerator spot? I need to factor it. So when I go to factor it, because we're talking about a situation of area and length, this has to simplify, or this should be simplifying nicely. Meaning that this 3a plus 7 is probably going to be up here. It's probably my common factor. So I'm going to use it to help me factor the rest of the expression. If I have 3a, what do I multiply it by to get to 12a squared? And if I have 7, what do I multiply it by to get negative 7? Negative 1. The only other thing I'm going to do is I'm going to check that my middle term would be 25a. Negative 3 and positive 28 equals 25. This allows me to cancel out my common factors and leaves me with 4a minus 1 as my width. So in part B, if the perimeter of the field is 54 meters, determine the value of A. How do I calculate perimeter?
Length times 2 plus width times 2.
So the perimeter is 2 of the length and 2 of the width. The question tells me that the perimeter is 54. The length from above was 3a plus 7. And the width we just calculated to be 4a minus 1. So now if we solve for a, I remove the brackets. And I get 14a plus 12. To get a by itself, I'd have to remove or get rid of the 12, so I'd subtract by 12 on each side. 42 would equal 14a. Divide by 14, and a would equal 3. The field is going to be treated with a fertilizer that is $2.40 per square meter. Calculate how much, or the cost of the treatment. So the first thing that I would need to find out about my field is what? And I know the area. The area is 12a squared plus 25a minus 7. And thanks to what I did above, I now also know what a is. A is 3. So I get 12 times 3 squared, which is 9, plus 25 times 3 minus 7. And what do you get? So 176 square meters. So then the cost is $2.40 per square meter, which is how much money?
$422.40.
Thank you. Okay. In class last example, number 4, we deal with 2 variables. So our restrictions look a little bit different this time. If I look at A, do they have any common factors, the numerator and the denominator? Not common terms, common factors. No. The x is attached to the y, so I can't cancel out x's because they're not common factors. So there's no further simplification, so now I look at the restriction. The restriction on the denominator is that x minus y can't equal 0. So if I write this in terms of x, it means that x can't equal, move the y to the other side, and it becomes positive. So in this case, all it means is that x and y can't have the same value. As long as they have different values, there would be no restriction. So if we look at B, can I factor anything from the numerator? It's not a difference of squares, so I can't factor anything. Can I factor anything in the denominator? What is the denominator? And so when I factor the denominator, what do I get?
X minus 5y, x plus 1.
And then I have to state my restrictions on the variable. So the restrictions on the variable is that x plus 5y cannot equal 0. So in terms of x, it means that x cannot equal negative 5y. And then I do the same thing with my x minus 5y. And I get that x can't equal positive 5y. And then to simplify my expression, my x plus 5y's will cancel, and I'm left with 1 over x minus 5y as my answer. Okay, if I look at C, what can I factor? So if I start off by taking a 3 out of the bottom, I get 3 times x to the power of 4 minus y to the power of 4. And then on the top, all I'm going to do is take that x plus y and write it out twice. Just so that remember, x plus y squared would mean x plus y times x plus y. What is the bottom? x4 minus y4. It's a difference of squares. So when I factor out that difference of squares, I get x squared minus y squared and x squared plus y squared. At the top I have x plus y and x plus y. And what is 6 divided by 3? 2. We're actually just going to write it as 2 right now. What do I notice about the 2 terms on the bottom? Yeah, I still have a difference of squares right here. Not here, because that's not a difference anymore, but in the first term I still have a difference of squares. So I have x plus y, x minus y, and x squared plus y squared. So this time when I look at my restrictions, I have that x plus y can't equal 0, which means x can't be equal to the negative y value. I have can't equal 0, which means x can't be equal to a positive y. And then I have x squared plus y squared. So x squared plus y squared can't equal 0, which means x squared can't equal negative y squared. But then when I go to square root it, I can't square root this because I can't square root negative y squared. So this, I wouldn't worry about. And really, if you look at this, would there ever be a situation where this would be negative? No, because if I take negative x and square it, I get a positive value. If I take negative y and square it, I get a positive y value. It's going to give me a positive y value here. So the last step, I eliminate like terms, and I get on the top 2 times x plus y, and on the bottom x minus y times x squared plus y squared. So your questions, 1, C and G, 2B, 3A, 6A, 7, 8, A and C, and 9 and 10.